Okay. Pilih satu.
Have you ever wondered why strawberries smell sweet, why butter has a rich taste, and why do freshly bread baked smell so delicious? Every day we enjoy countless food because of a fascinating group of organic compounds known as carboxylic acid derivatives. These compounds are responsible for the flavors, aroma, texture, and preservation of many food we consume. Today, we will explore the chemistry behind these molecules and discover how organic chemistry shapes the food we eat and the flavor we love. Welcome to Carboxylic acid derivative, the chemistry of food and flavors.
I'm so thirsty. What should I get, Ellie?
What about chrysanthemum tea because it's always tastes refreshing and smells so nice.
Oh, it was a great choice. I always wonder, is it every bottle have the same floral taste and aromas, or it depends on the flower?
I think so.
Aha! Actually, that's a great question. The answer actually involves around the carboxylic acid derivatives, which is ester. Okay, what does it mean? Esters are organic compounds that form when carboxylic acid reacts with an alcohol. Many esters have pleasant, fruity or floral aromas, which is why they're widely used in the food industry and beverage industry as flavoring compounds.
So, ester can make tea taste like flower.
So, the main floral flavor comes from natural compounds extracted from the chrysanthemum flavor. However, food scientists may use flavoring compounds containing ester to enhance or maintain the consistent flavor and aroma. So, every bottle provides the same refreshing experience.
Oh, that's why every bottle has the same taste.
Exactly. Since the flavor of natural flowers can change depending on the seasons or growing conditions, flavor chemistry can help to keep the product consistent while still delivering the same taste that consumers expect.
Oh, I never thought it was so chemistry in the bottle.
That's the amazing part of organic chemistry. Compounds like esters help to create the flavors and aromas that we enjoy every day.
Now, let's discuss the physical and chemical properties of esters. Physically, esters are usually colorless liquids with sweet and fruity odors. They are volatile compounds, meaning they evaporate easily into the air. Because of this property, we can quickly detect their smell. Chemically, esters are slightly polar molecules and are generally less acidic than carboxylic acid. They can undergo hydrolysis reactions, where they react with the water to produce a carboxylic acid and an alcohol. This reaction can be represented as ester plus water to produce the carboxylic acid plus alcohol. Next, for the chemical structure of ester, first let's look at the chemical structure of the esters. The general formula of an ester is RCOOR', where R and R' represent alkyl groups derived from a carboxylic acid and an alcohol. One common example is isoamyl acetate, which is responsible for the characteristic smells of bananas. The ester functional group is COO, and this functional group gives esters their unique chemical properties and the pleasant aromas. The aroma of esters is closely related to their intermolecular interactions. Ester mainly experience dipole-dipole interactions and London dispersion force. Unlike alcohol and carboxylic acid, ester do not contain a OH bond, so they can form strong intermolecular hydrogen bonds with each other. As a result, ester molecules are held together less strongly and can evaporate more easily. This allows them to enter the air and interact with our olfactory receptor, giving rise to the fruity smells we recognize. Moving on, esters are commonly prepared through a process known as Fischer ester verification. In this reaction, a carboxylic acid reacts with an alcohol in the presence of concentrated sulfuric acid as a catalyst. The general reaction is carboxylic acid plus alcohol produce ester plus water. For example, acetic acid reacts with isomer alcohol to produce isomer acetate, which give the aromas of banana. Sulfuric acid is used to increase the reaction rate and improve the yield of ester produced. Let's now examine the reaction mechanism. The mechanism consists of several steps. First, the carbonyl oxygen of the carboxylic acid is protonated by sulfuric acid. Second, the alcohol acts as nucleophile and attack the carbonyl carbon. Third, a tetrahedral intermediate is formed. Next, a water molecule is removed from the intermediate. Finally, the protonation occurs, producing the ester product. Since water is produced during the reaction, esterification is classified as a condensation reaction. There are two reactions involving esters. The first is esterification, which produces flavoring compounds used in food, such as candies, beverage, chewing gum, and desserts. For example, ethanol reacts with the acetic acid to produce ethyl acetate, a compound with a pleasant aromatic aroma. And then, the second reaction is hydrolysis. During hydrolysis, an ester reacts with water to regenerate the original alcohol and carboxylic acid. This reaction may occur under acidic or basic conditions, and it is important in food processing and industrial applications.
Next, I will explain the chemical reactions that are important in food processing and contribute to food flavors, color, and quality. The first reaction is the Maillard reactions. This reaction occurs when amino acid reacts with reducing sugar at high temperature. It is responsible for the brown color as well as the rich flavor and aromas found in food such as toasted bread, grilled meat, and roasted coffee. The second reaction is a caramelization. Unlike the Maillard reactions, caramelizations only involve sugars. When sugars are heated, they break down and form new flavors compounds, producing a sweet, nutty, and caramel-like taste. Common examples include caramel sauce and brown onions. The third reaction is oxidation. This is a chemical reaction between food components and oxygens. Oxidation can negatively affect the flavor, color, and overall quality of food. A common example is sliced apples turning brown after being exposed to air. Lastly, fermentation is a process where microorganisms convert sugars into acid, gases, or alcohol. Fermentations not only create unique flavors but also help preserve foods. Examples include yogurt, cheese, bread, and fermenting beverage. Overall, these chemical reactions play an important role in determining the taste, appearance, aroma, and shelf life of many foods.
As we discover, esters are more than just a chemical compound. They are the key of many flavors and aromas we enjoy every day. Their unique molecule structure allows them to evaporate easily, carrying their pleasant fruity scent to our sense of smell. Through reactions such as Fischer esterification and hydrolysis, scientists can produce and understand this important compound from beverage to candies and many other food products. Esters play a vital role in creating the flavor we love. By understanding the chemistry behind food and flavor, we can truly appreciate how organic chemistry enhances our everyday life. Thank you for watching.